So what's better, Sydney's tap water or rainwater from the country? Aussie legend Shane Jacobson is going to find out by putting rainwater from his own property to the test.
Here's the water I'm giving my family, safe to drink.
And the results might not be what you'd expect.
What does that mean?
But the biggest surprise, a new source of water that's entirely drought-proof.
This is the future though, isn't it?
I think so.
The world-class project being tested right now in Sydney.
You do much more than just clean water here, don't you?
There's a lot going on behind the scenes.
We take you inside Sydney's mega projects, delivering the good old H2O to your tap. Think you know where your water comes from? Think again.
G'day, Shane Jacobson here, coming to you from this little slice of paradise in the country. You know, I've always thought that one of the best perks of living in the country is getting to drink the cool, crisp, clean rainwater from my property. I mean, it's nature's own right, yeah. Well, the other day, one of my mates threw me a bit of a curveball.
She said, Shane, how do you know the rainwater you love so much is up to scratch? Even though it comes out of my kitchen tap, it doesn't go through the same treatment and testing as Sydney water. Now, I'm not one to shoot my mouth off without backing it up. So what we're about to do is go on a journey of discovery into what's flowing through Sydney's water pipes. Well, let me tell you, it's one ripper of a ride.
We'll be checking out some remarkable spots from the mighty Waramber Dam to the high-tech Prospect Filtration Plant, and even get a sneak peek at how Sydney is planning to deal with the future. That means factoring in things such as droughts and a population that's already 3 times what it was when Waramber was built. And just to make sure we're not spinning yarns, the facts in this video have been given the thumbs up by the Independent Australian Academy of Science. That should do it. Looks good to me. But I guess it's what you can't see that matters. Okay, the time has come for a little water showdown. We are off to the city where I suspect things are going to get very interesting. Okay, well, this is where we find out exactly what's in my water. And I've got to be honest, I'm a little bit worried. You know when you take your car to get it checked for its rego, and you're pretty sure everything's right, but you are still a little bit worried. Anyway, let's do this. This is Australia's largest water testing facility. They have samples coming in from right across the Sydney region every single day. Jono.
Shane,
Hi, mate.
ready to put your water through the paces?
Yes, please. John's one of the scientists here and has been given the task of analysing my rainwater. What kind of things are you looking for when you run a test on water samples like this?
So we're testing a whole range of things from bacteria to parasites to chemical contaminants.
They're the same tests that guarantee Greater Sydney has some of the best drinking water in the world.
So Shane, what we're testing here is E. coli in drinking water samples.
Oh, okay, and you obviously don't want that.
No, and this is a controlled sample, and if you look under here, it fluoresces under UV.
Look at that. That's incredible. So this positive control sample is obviously contaminated, so that's bad.
Yes, and if you look at this nice clear sample, that's what you really want.
So if you put that in and nothing fluoresces, that's how you know.
Absolutely, I'll show you. Get your snoz in there.
Wow.
Perfect, isn't it?
Clear as a bell. But that's just one of around 70 tests that they do on drinking water alone.
So in here, Shane, we test for pH, conductivity, alkalinity, also turbidity on all of our drinking water samples.
And this impressive piece of kit tests for metals such as lead.
So basically what happens, it gets sucked up in this tubing, it goes through this chamber and into a plasma, which is as hot as the surface of the sun.
As hot as the surface of the sun? Why does it have to be that hot? What does that do?
So what it does, sample goes through, it vaporises the sample and it spits out a result.
And it doesn't end there. This place has lab after lab and test after test.
Pesticides and herbicides, pharmaceuticals. We've also got PFAS, which is tested here as well.
Ah, yes, of course, those pesky forever chemicals, yeah?
Absolutely.
You know, seeing how much they analyse Sydney's drinking water is making me think my mate could be right. I have no idea what's in mine.
So you're going to do all this testing you've shown me here today on my water sample?
Yes, absolutely.
That sounds like it's going to take a while.
Yeah.
Yeah, it is. I may not stick around. I may leave you to do your magic work here. I'm going to go on a road trip and follow the path of Sydney water.
And we'll have your results ready for when you get back.
So, mate, we'll see you then.
Have a good time.
Holy dooly, have a look at that. I mean, that's not just a dam, that's more like an inland sea. And I'm told it goes 50 kilometres that way from this dam wall. So what we're seeing here is less than 10% of it.
And this beauty here, believe it or not, supplies 80% of Greater Sydney's water needs. Waramber Dam is actually 105 metres deep when it's full and holds 4 times more water than Sydney Harbour.
G'day Shane, I'm Ronan.
Ronan is from Water New South Wales, which manages the dam.
It is the most protected water source in the world, isn't it? Or one of them?
Yeah, no boating, fishing, no camping, walking, biking, it's all closed, so fully protected.
The dam took 12 years to build, a remarkable undertaking made necessary by Sydney's growing population.
So, mate, where does all the water behind that wall come from?
Shane's been on a really big journey. So that catchment there stretches all the way down to Goulburn, and the water comes from both the Wollondilly and Cox's rivers and then makes its way through the catchment right up to the dam wall.
So from here, do you, when required, you just release that downstream to go to a plant from here where it's filtered?
Yeah, not quite. So we select the water through various layers to make sure we're sending that great quality water down through the treatment plant.
So like a lasagna, you can literally pick the layers of water that are best at any time and only release that layer.
Absolutely. And it's really important. So the team are looking at data they've captured as the water's coming in and real-time data, and they're analysing that to make sure we're picking that really good quality water.
I've got to admit, I just assumed you had some big gate that opened up and you just let it out, and when you let out enough you shut it, but it's far more scientific than that.
It's certainly, it's a bit more challenging and a lot more thought goes into it.
In fact, that big gate only opens in times of flood. And boy, isn't that a force of nature.
So as we stand here, this looks pretty quiet, but right now there's water that we can't see through pipes being fed now to treatment plants.
That's right, spot on. The water travels 26 kilometres through these pipes right down to Prospect.
Well, that sounds like where I should go next, yeah?
Yeah, absolutely.
Thanks for your time, mate.
Thanks for coming, Shane.
Which way is it, that way?
Yeah, that way, mate. Off you go.
26 kilometres. This is going to take a while.
This thing just keeps going. You know what's ironic? I really should have brought some water. And maybe my car. Well, it's a good thing that Trace is here to save me.
Shane,
Tracy,
nice to see you.
how are you? Oh, I'm glad to see you.
Here's the thing that gets me. These pipes just get the water from Waramber to the treatment plant. How many more pipes must there be to get the treated water to everyone's home?
Shane, if we're talking about drinking water, we have over 23,000 kilometres of drinking water pipes underground, so invisible to most people.
Yeah.
But they service our entire area of operations.
And wastewater pipes, are they completely separate?
Completely
I would hope
separate.
they are, yeah.
Completely separate, over 27,000 kilometres worth of pipes.
So altogether over 50,000 kilometres of piping.
Yeah, and if you do the math on it, it actually means if you connected them, you could wrap the Earth 1.25 times.
That is unbelievable. So how on earth do you maintain that amount of piping?
So we have an amazing team of field operators and maintenance crew that go out and check all of those pipes. So Sydney Water really loves innovation. We've got robots, leak detection dog teams.
Oh.
Yeah, they're awesome. They do great work, and they also maintain our pipe network.
Pretty amazing stuff, but I better get back on the road to see where these two big pipes end up.
I gotta go that way, my car's that way.
Good to see you, Trace.
Really nice to
Thanks for your time.
Bye, Shane.
I'll
Take
see.
care.
Yeah, thanks, mate. Whoa. This is where it all happens. The Prospect Water Filtration Plant is one of the largest in the world, providing up to 1.5 billion litres of reliable drinking water every day.
So yes, the water that you see here comes straight from Waramber Dam and it will go straight into our Prospect Filtration Plant.
Right, so it's not drinkable at this point, is it? Where does it go to from here?
It is pretty clean, but it still have to go through our filtration process to make it drinkable.
Right, so it goes through this channel here and then through filtration.
Correct.
So right here, it's dam water, and when it gets out the other side of the filtration system, it'd be fair to say it's damn good water.
Sure it is.
You know, this site really is epic in scale, but as complex as it looks, much of the hard work has been left to gravity. The water enters the plant from an elevated source, then flows downward through various filtration systems, reducing the need for electricity. Think that's cool? Wait till you hear what they do with the water.
So how do we turn this into clean drinking water?
Yeah, so once we get the dam water, we use a 4-step process: coagulation, flocculation, filtration, and disinfection.
Okay, that was great. Except could you maybe explain it for us simple folk who don't understand all those big words?
Yeah, let me simplify it a bit.
Please.
So when we get the water, we add small amounts of chemicals called coagulant, which allow all the small particles in the water to stick together and form clumps, which we call flops. We can then run that water with the flops through our filters here, and that removes them, and we have clear water on the other side, which we can then dose chlorine to disinfect before we send it out to the network.
That makes sense. The only thing that doesn't make sense is that I'm up here and you're down there, because it's not until I do this that people realise actually how tall you are. I'm going back up here.
The Prospect Filtration Plant supplies around 80% of Greater Sydney's drinking water.
This is the monster that never sleeps.
Yes, it is.
It just never stops.
As impressive as this is, turns out it isn't the only way Sydney gets its water.
Now, you might be thinking, Shane, mate, what are we doing at the beach? I thought we were talking about drinking water. Well, believe it or not, this big blue ocean behind me is another source of the drinking water that comes out of your tap. This is Sydney's Desalination Plant. This is where they somehow turn seawater into drinking water. How's that for a party trick?
This plant can produce up to 250 million litres of drinking water a day, meaning it currently supplies up to 15% of Greater Sydney's drinking water, even when our dams are full.
So I've got to ask, why would we need to use this desalination plant when our dams are full?
For one, having the desal plant here gives us the ability to do maintenance on other parts of the network, be it dams, other treatment plants. Two, if there's any emergencies, the desal plant's available and can respond. So things like natural disasters, whether it be a bushfire or a flood, anything that might impact the dam. And so when those events occur, the desalination plant's here to ramp up, take the load off the system and ensure that we continue to get good quality water out the door.
That's pretty smart thinking, especially as Sydney continues to grow. We can't expect the dam to handle everything, right?
This energy system here...
Now, we know how dams work. What about desalination?
In this building, we have high pressure pumps that are running at about 60 bar or 600 metres of pressure. So
I take it that's a lot of pressure.
It's a lot of pressure. Okay. So if we held your garden hose here, the water would go 600 metres up into the air.
Oh, that's a lot of pressure.
So it's a lot of pressure.
Right.
So the high pressure forces water through the pores in the membranes. The salt particles are too big, and it's only the clean water goes through to be made into drinking water.
So the membrane is in these tubes, I take it?
That's right. So each one of the white tubes you can see behind us has 8 membranes end to end inside.
So it's like a coffee filter but for salt?
Sure, Shane. Yeah, something like that.
Reese prefers to call it by its official name, reverse osmosis. Once done, the water is so clean that it needs minerals to be added to it before being fluoridated and chlorinated and ready for drinking.
So from here, we've got a 1.8 metre diameter pipeline, so a big pipeline that transfers the water 18 kilometres from Kurnell all the way into Erskineville, and the water is distributed across Sydney from there. So our water can reach as far west as Parramatta, heading out to the western suburbs, and as far south as the Sutherland Shire.
That's impressive stuff, and this entire plant is 100% powered by renewable energy. Renewing is also the name of the game at the final stop of my journey of discovery. Behind these gates, they are testing a revolutionary process with the potential to secure a brand new source of water for Greater Sydney. One that doesn't stop even when drought hits, which is a good thing when you live on the driest inhabited continent on Earth.
So this whole plant was constructed over the last few years.
I'm at the Quakers Hill Water Resource Recovery Facility in Sydney's West, where they treat wastewater from businesses, industry and homes.
So as you can see, we've got this beautiful aeration pattern at the moment. So we're adding some air to this product, and that's to help remove some of the nutrients, things like ammonia that our waterways don't like. Once we get rid of that, that goes into the next part of the treatment process where we clean it further, get rid of things like phosphorus.
The goal is to get it clean enough to release it back into nearby creeks. But here's the thing, that process results in a lot more than just clean water.
Now, there's something you do with the gases, for the want of better terms, that come off this that makes you self-sufficient. How does that work?
Yes, we can create biogas. From our digestion, we can create a methane, which we can burn as a renewable energy to power either our plants, or we can put it back into our grid.
You do much more than just clean water here, don't you?
There's a lot going on behind the scenes.
Yes, there is.
But there's something even more remarkable happening right next door. A state-of-the-art prototype that could be the key to future-proofing Sydney's water supply. Some of the wastewater that's being cleaned at the Water Resource Recovery Facility is then directed here to the Purified Recycled Water Discovery Centre. The question is, can we make it so clean it's okay to drink?
So, Stella, where we are now, this is the final part of the process, is that right?
That's right.
Okay, so what happens here?
Yeah, so the water goes through an ultrafiltration, reverse osmosis, UV advanced oxidation process, and then the chlorination process after that.
I imagine that's exactly what needs to happen to this water for it to be good water. And then where does it go to from here?
So currently it's going to go back to the creek.
So you're telling me at the moment it goes from here straight to a creek. So perfectly good water is going into a creek, not into our dams or water storages.
So currently we're going through testing for this water. And in the future, we hope that we will get it added into our dam reservoir to be able to be used for our drinking water sources in the future.
This is the future though, isn't it?
I think so.
I think so too.
In fact, purified recycled water has the potential to provide up to 25% of Greater Sydney's water by 2056. Well, it's been quite a journey from Waramber Dam to the Prospect Filtration Plant, the Sydney Desalination Plant and the Purified Recycled Water Centre. Everything they're producing meets Australia's strict drinking water standards. But one big question still remains.
Oh, here it is. Why am I nervous? Why am I so nervous?
Shane.
How are you, mate?
Good.
So, give me the news. Is the water I'm giving my family safe to drink?
Oh, it's not terrible.
What does that mean?
I'm only joking with you.
Kill me. Go on. What did you find then?
We did find some low-level bacteria and organic matter.
Like of concerning levels, or you mean low level?
We mean low.
Oh, right, okay. So it is okay to drink?
It's absolutely safe.
But let me guess, they're not up to your standards?
No, our standards are very high.
You know what? It's okay news for me, but it's great news for the people from Sydney, isn't it?
Absolutely.
Mate, thank you so much.
You're welcome. Thank you, Shane.
Just one more time, it's okay to drink, yeah?
It is, absolutely.
I'm not killing my family. Good.
No, you're not. No,
Cheers,
nothing to
mate.
worry about. It's all good.
Now, I've got to be honest and say that I had no idea how much work goes into making sure we've got water at our taps. I started this whole journey just to defend my water, and it turns out my water's okay. But it also turns out it's not as good as Sydney water. There's no doubt about it, they go above and beyond to ensure that we have fresh, clean drinking water. That's why they say it's not just water, it's Sydney water. You know what I say? I'll drink to that. Oh, it's a lot of effort. God, it's good.